এই গ্রুপ এ আর গ্রুপ বি সবাই স্লাইড দেখতে পাচ্ছ তো?
হ্যাঁ স্যার, একদম ক্লিয়ারলি দেখা যাচ্ছে স্যার।
আচ্ছা, লাস্ট ডে মিন্স
স্যার ওই বাটনটা একটু অফ করে দেবেন তো, এই ট্যাব যেটা খুলে রয়েছে লাস্টের লাইনটা পড়া যাচ্ছে না। হ্যাঁ এবার ঠিক আছে, একদম পারফেক্ট স্যার,
in
একদম
the
স্যার।
last class we have discussed about how what is the usefulness of the theodolite, means how to measure the horizontal angle, how to measure the vertical angle, how to measure the deflection angle, how to measure the magnetic bearing, how to prolong a straight line. Up to this slide we have discussed in the last class, that means on 4th of October, right? Up to this slide we have discussed what is the usefulness or what we can do with the help of the theodolite, that we have discussed. Now the point is, all this process we have discussed. Have bolo keu kichu bolcho? Okay. So all this process, although we have discussed in the last class, we have not discussed any numericals based on this, because all the numericals of this part we will discuss in the next module, that is traverse surveying. In the traverse surveying, basically we will apply all this knowledge, how to calculate the horizontal angle, how to calculate the vertical angle, all this we will apply and we will plot our traverse. Okay, so this, all the numericals related to all these parts of theodolite will be there in the traverse surveying part. So obviously we will discuss all the numericals based on this usefulness. In this module only we have discussed till now different parts of theodolite and how to measure with the help of the theodolite. And we have also noticed that before taking any measurements, what are the necessary steps we have to follow. Like we have to do the temporary adjustment or simply centering, leveling, all these sort of things. Now, except this also, there are certain kind of other sort of errors. And to minimize those errors, we know some of the steps, what we are doing while taking the measurements. Like we are taking the measurements of both the verniers, so obviously this is basically to reduce some amount of error. What is the type of the error, that we will discuss, but obviously this step we are doing to minimize the error. Similarly, with the help of the method of repetition and reiteration also, we are actually going for a more precise measurements, right? Or basically we are reducing the error also. There are certain other kind of errors also. So we will discuss what are the types of the errors that will involve while taking measurements with the help of the theodolite. So that today we will discuss. Now before going into that part, that means what are the different types of errors, we have to know what is the exact condition that a theodolite should do. That means what is the desired relation of different axes of the theodolite. Now suppose you are placing your eye here. Okay, and through this you are looking, and this is your objective, this is your eyepiece. So obviously there is optical center and your line of sight should pass through the optical center. That means the crosshair's midpoint and this optical center should form a line, and which is your line of sight, right? Then we know the Trunian axis is actually passing through this, that means through the center, and like already we have shown the Trunian axis. If you go to the diagram, then you will see very first few classes. You can see So you can see this will be the Trunian axis, the axis passing through this point and here, and this is your line of sight or line of collimation. Ideally it should be at 90 degree. Similarly, the vertical axis is also there, right? So vertical axis also should be perpendicular to this horizontal axis or Trunian axis. So all these relations should be there. So let us go to that slide again. Yeah. So you can see this is the Trunian axis, this is the line of sight or line of collimation, and this is the vertical axis. So your axis plate level must lie in a plane perpendicular to the vertical axis. You can see this is the plate bubbles. So your axis plate levels should be in a plane which is 90 degree to the vertical axis. This should their first relation should be this one. The second one is that your line of collimation, that means this axis must be perpendicular to the horizontal axis. So this angle should be 90 degree. Okay, must be perpendicular to the horizontal axis at its intersection with the vertical axis. So if you look at the intersection of line of collimation and vertical axis, that means this one, at this point this line of collimation should be at 90 degree with the Trunian axis. You have to remember this now, because if this is not 90 degree, if there is any defect while manufacturing, or if there is any defect in the instrument while manufacturing, obviously there will be some sort of error. What is the kind of error, how to remove that, we will discuss that. But please remember that it should be 90 degree. Similarly, horizontal axis must be perpendicular to the vertical axis also. So this vertical axis must be perpendicular to the horizontal axis also. That means this angle also should be 90 degree, like this. So these are the three axes you can see, like XYZ, like our orthogonal axis. You can assume this is the line of collimation, this is the horizontal axis or Trunian axis, and this is the vertical axis. So these three should be like a right-handed means coordinate system, or simple a 90. All these axes are at 90 degree. Okay. So these three should be at 90 degree, like this already I have mentioned. Now your axis of the altitude level or simple telescope level must be parallel to the line of collimation. Okay. So your altitude level is this one, and your axis to the altitude level is this one. So this must be parallel to this line of sight, as you can see. Another one should be vertical circle vernier must be 0 when the line of collimation is horizontal. That means when it is horizontal, the vertical circles should give you 0. এখনো জয়েন করে যাচ্ছে কারা? Okay. So all these relations should be maintained. Now, if these relations are not there, that means if these are not valid, or at least it is not 90 degrees, say it is 89 degrees something minutes, then also there will be some kind of error, and we will discuss what is those error. Remember, whenever this object, this line of collimation is horizontal, if at that time the vernier is not 0, that means there is some sort of index error. Okay. Now, whenever we are discussing the error of theodolite, there can be three type of error. First one is instrumental error. Obviously, there will be some sort of manufacturing defect can be there, as all this instrument is manufactured in some machines, but there also some sort of error can be there. Okay. So how to manage those errors, we have to learn these things. Then there is personal error. While taking the measurements, maybe a person is doing some error. So this error is very hard to remove. What you have to do, you have to be very careful while taking the measurements. Only then you can remove this sort of error. And then there is natural error, which is also very hard to remove. The instrumental error you can remove by taking different types of measurements. Means more number of measurements. By taking more number of measurements, you can minimize this kind of error. So for instrumental error, what are the type of instrumental error? As you can see, not this sixth one, or another two error is also there. So there is imperfect adjustment of plate level. That means if the plate level is not this plate level, if that is not adjusted properly, if it is tilted like this, then obviously there will be some kind of error. Okay. Then there is line of collimation. If it is not perpendicular to the horizontal axis, already I have told you that if your line of collimation, that means this line of collimation, this one, if it is not at 90 degree with the Trunnion axis, say this is the Trunnion axis and this should be ideally 90 degree, but say this is making an angle of 89 degree 40 minutes instead of 90 degree. Then whenever you bisect a object and you will go down, it will not be suppose you have bisected a object P and from a telescope. Now you are going down. So ideally it should be 90 degree on a horizontal trace or on a horizontal plane, but it will not be 90 degree. Neither it will be a perpendicular straight line. It will follow the curved path of a hyperbola. Remember. So this kind of error will be there. Now, if then there is error due to horizontal axis not being perpendicular to the vertical axis. So if your this angle is not 90 degree, say it is 89 degree 40 minutes, or it can be 90 degree 20 minutes, this kind of error can be there, or 90 degree 10 minutes, 90 degree 5 minutes, or something like that, something error is there. So at that time, whenever you are bisecting a object and going down, the theodolite will follow a plane of curved ones. That means it will not be a perpendicular or 90 degree, it will be like this one. This is an exaggerated version. Maybe this angle is like say 89 degree 40 minutes or something, but this will form a curved inclined straight line path. So when you do not have the angle between horizontal axis and the vertical axis as 90 degree, it will follow a curved straight line path like this one. And whenever this is not 90 degree, that means line of collimation and horizontal axis is not 90 degree. Whenever after bisecting you are going down, it will follow a hyperbolic curve. Then there is some error due to non-parallelism of axis of telescope also. Then there is other error like error due to imperfect Hubble. Follow? Hyperbolic pathটা কিভাবে আসছে না? Suppose okay, at the time of error I will just again explain. Okay? Now, then there is error due to vertical circle vernier. Error could be due to the eccentricity of the outer axis and the inner axis. That means if your vernier plate and main scale plate, their axis, if it is not passing through the same point, then also there will be some kind of error. So then there will be error due to imperfect graduation. Maybe it is formed in a factory, So ideally it should be like 0, 180 and 90 and 270. But say in actual case within this 1/4 you are having actually 89 degree, and within this period, that means within this quarter you are actually having 91 degree. So obviously your some kind of error will be there if you are taking in this quarter or in this quarter, right? Are you getting my point? Means ideally it should be spaced equally 0 to 90 within this one quarter, but there may be some sort of imperfect graduation. The graduation is not proper, and due to the imperfect graduation in this one quarter, the reading is say 89 degree. 89 degrees spaced in this one quarter, and it may happen in the next quarter the spacing is 91 degree. Like this sort of imperfect graduation can be there. So how to avoid this kind of error? So we will discuss that part. So let us discuss the first part, that is imperfect adjustment of plate level. If the plate level is not perfectly adjusted, if it is not perfectly leveled, okay, then what will be the kind of error? So if upper and lower plate are not horizontal when the bubbles in the plate levels is centered. So if the bubbles in the plate level is centered but still horizontal, and your lower and upper plate is not horizontal, then vertical axis of the instrument will not be a true vertical. So if it is not a true vertical, if the axis of the instrument is not true vertical, then obviously your measurements will not be in a horizontal plane, rather in a inclined plane. Instead of horizontal plane, it will be in a inclined plane, like this, instead of horizontal plane. This is an exaggerated version, but it will be similar to this one. So it is the perfect vertical, but this will not be the actual case. When your instrument is inclined or it is not properly labeled, imperfect adjustment is there, at that time it will be like measurements in a inclined plane. So here not only the horizontal angle measurements will be wrong, the vertical angle measurements also will be problematic. So how we can uh, minimize this error? This error is very basically uh, very serious kind of error. If you do this kind of if this kind of problem is persist, then there will be little bit higher amount of error. Okay, so how to remove this error? You have to carefully level with respect to even the altitude bubble. So with respect to the bubbles, altitude bubbles and the normal bubbles, you have to carefully level the instrument. Then only you can minimize this kind of error. The second one we will discuss, that is line of collimation is not being perpendicular to the horizontal axis. That means ideally whenever you are seeing, you see this is our instrument, this is our instrument point, instrument station, like this. So at first you have bisected this P and you are having another object. Suppose this is the back side and this is the foresight. You are taking you are bisecting the back side first, then you will bisect the foresight. So you want to measure this angle. Say this is P, this is Q, and here is your instrument. So you will surely bisect this one, then you will bisect this one. So you will basically measure this one, but actually in a horizontal plane. In a horizontal plane. See this one P1, this one Q1. So basically you want to measure this P1AQ1, this angle you want to measure. Now what will be the problem if the line of collimation is not perpendicular to the horizontal axis? So whenever I am measuring, my horizontal axis is passing through this one and line of collimation is this one. So line of collimation and horizontal axis should be 90 degree. But if this is not 90 degree, if this is 89 degree, or say 90 degree something second or something minute, whenever after bisecting you are going down, it will not follow a straight line or a or path of a perpendicular to a plane. It will not follow that kind of path. Rather, it will follow a it will follow, or it will give you a curved path like a cone. This sort of path it will give. So this is by experience. When you will see, or when you will observe the measurements through this one, you will see this kind of path will follow. This is scientifically proven. Okay. So whenever this angle is not 90 degree, that means if you see line of collimation and this angle is 89 degree or something minute, and you are going down, you will follow this kind of path. Instead of this one, you will follow this kind of path. Okay, is it clear, this part? uh,
Yes, sir.
so as it is following a conical path, ideally what angle you should measure? P1 AQ1. But if it will follow a conical path like this one, then what will happen? Instead of P1 you are getting a point P2, instead of Q1 you are getting a point Q2. So ultimately you are measuring P2 A Q2 measure. So there is a shift, right? And what will be this shift? P1 P2 will be the shift. Here there will be some shift, like Q1 Q2 will be the shift. So ultimately in the angle measurements, your error will be, some amount error will be there. Now if you calculate this value like P1 P2, this value if you will calculate, that value will come as, this P1 P2 value will come as beta into sec alpha 1. Now what is the beta here? Beta is the error in the collimation. That means if your line of collimation is not perpendicular to the horizontal axis, this is the horizontal axis, this is the line of collimation. Line of collimation means this line through which you are seeing the object. So if this is not perpendicular to the horizontal axis, so this angle is not 90 degrees, say this angle is 89 degree, 59 minute, say 45 second, then what is the error? Then line of collimation error will be beta, will be 15 second, because it is not 90 degree. How much it is differing from 90 degree, that we have to measure. So the error in line of collimation will be 15 second. Is it clear? Error in the line of collimation will be 15 second. Is it clear?
Yes, sir.
Now whenever you are seeing an object from an horizontal surface to the tip of that object, when you are seeing, obviously this object P is making some angle like this angle, you can see this angle, and say this angle is alpha 1. That means angle PAP1 is your alpha 1. Then by several deduction we can prove this P1 P2 is beta sec alpha. Now don't get into this how this is coming. We can prove that. You can look at the book of the Schofield, which I have already told you in the beginning of the class. Also, you can look on the other textbook, like you can look at Kanitkar Kulkarni. On all these books, the derivation is there, but I am not going into the detailed derivation. Why? Because that is not necessary. How to optimize that error, we will learn that. Okay. How this calculation is coming, I am not going into this. Nowadays, theodolite is even becoming obsolete. You are going for a higher grade of instrument. So you should ideally know what is the kind of the error, how this error should be minimized. Not not going into the details of this derivation. That is not needed. Okay. So this P1, P2 from the calculation of the derivation, from the derivation we can prove that it will be beta sec alpha 1. So it will be beta sec alpha 1. Now the total error that we are making, that is P1, P2, is beta sec alpha 1. That we can prove our by our derivation. Now as we are telling you that you are basically measuring the angle. Just add me one another slide. Say yes. Now say you are measuring these two objects and these two at a different level. This is P, this is Q. Sorry, this is P, this is Q, and you are measuring from a point like this, theodolite. So you have measured this one and you will measure this one, bisect this one. So back side and forth side. Ideally what you are doing, you are taking the projection in a horizontal plane, say this one P1 and this one Q1 and say this one A. So ideally you are measuring P1A Q1, this angle you want to measure. But actually if you are having some sort of error between the line of collimation and the horizontal axis, it will not follow this path. So it will follow like this path. So instead of P1 you are measuring P2. Instead of Q1 you are measuring Q2. So obviously here also you are moving in the left side a little bit. Here also you are moving a little bit in the left side. Now remember, if this angle is alpha 1 and while seeing Q, if the angle with the horizontal plane is alpha 2, then the error here, that is Q1, Q2, this error will be how much? It will be beta sec alpha 2. Like in case of the P1, this is the P2, the P1, P2 error, P1, P2 error is like beta sec alpha 1. Similarly here, Q1, Q2, this error, Q1, Q2, this error will be beta sec alpha 2. So it is depending on this angle. Not only the error in the collimation but also this angle. Alpha 2, if this one is alpha 2, then this error will be beta sec alpha 2. Similarly here the error is beta sec alpha 1. So what is the ideal error? What is the actual error that is happening? So the actual error is happening beta sec alpha 1 minus beta sec alpha 2, right? There is some measurmental error here, there is some measurmental error here. So instead of this one you are measuring like this. So there is some kind of error. So to get their error, what we have to do, we have to calculate the error, and the error will be this minus this one, right? So beta sec alpha 1 minus beta sec alpha 2 is the error. Is that clear? Is it clear to you why beta sec
Yes,
alpha
sir.
1 minus beta? Is it clear to everyone?
Yes, sir.
Now, from this point, if it is clear, that is the error in ultimate angle measurement will be beta sec alpha 1 minus beta sec alpha 2. Can you say when the P and Q will be in the same level? Say P and Q is in the same level, the height from the horizontal level is same. Then what will be the error? The error will be 0. Why? Because from the horizontal with the theodolite, it will make similar angle. The angle will be similar, alpha 1 and alpha 2. Alpha 1 and alpha 2 value will be similar. If P and Q is at the same level, if they are at the different level, obviously the error will be there. But if alpha 1 is nearly equals to alpha 2, the error also will be nearly 0. So obviously, this sort of error is not prominent when both the object are at the same level. But if the level between both the object is different, obviously the error will be a considerable one. Now, how to minimize this error? As this error is present while the level difference is there, so how to minimize this error? So till now we have discussed the measurements with respect to face left operation. Now if you do face right operation, then again it will not follow this path, it will follow the path on the other side, or it will follow this P1 P3 trajectory when you will go for face right operation. Face left, face right operation already we have discussed, right? So whenever you will go for face right operation, the this sort of curved path it will follow. So ultimately the P1 P3 value will be similar to P1 P2. Hence, if you take both the measurement face left and face right, and if you take the average of these two, then obviously you will get the actual position of P1 or the measurements with respect to AP1, measurements with respect to AP1 line, right? Ideally, when you are following this curved path, whenever you are taking the measurements, you are taking the measurements with respect to AP2 if you are going for face left. If you are going for face right, when you are going down, you are basically following this curved path like PP3. So ultimately your measurements will be with respect to AP3 instead of AP1. So if you go for both the measurements and if you take the average, then you will actually get the measurements which is with respect to AP1. Hence, we can eliminate this error by taking both face measurements. That means while taking any angle or measured any angle, we will measure first with face left swing right measurements, and then we will again measure this angle by face right swing left measurement. Is it clear? Is it clear?
Yes, sir.
Okay. Now say, till now we have discussed that the line of collimation is not perpendicular to this horizontal axis. Now what we will discuss? Now we will discuss that the horizontal axis not being perpendicular to the vertical axis. So if this is not vertical, if this is say 89 degree, then this line of collimation, if you going down, it will follow a inclined path like this one. So instead of PP1, when by after bisecting, if you going down, instead of PP1, it will follow a trajectory of P2. Hence, any measurements of the angle, you want to measure this P1, AQ1. So your measurements will be with respect to this line. Basically, this line on the back side you are making 0 and you are opening your vertical. You are opening your screw so that your vertical scale will move, and ultimately you want to bisect this AQ so that your P1 AQ1 this angle will be measured. But whenever you will going down, when there is not a 90-degree angle between the vertical axis and the horizontal axis, it will follow an inclined straight line path like PP2. Hence, your measurements will not be with respect to AP1, rather it will be with respect to AP2. So there will be some kind of error. The error is P1, P2. The error is P1, P2. Now, what is the amount of the error? If you look at this triangle, you can see that this is the beta or the error between the horizontal axis and the vertical axis. If it is perfectly vertical, if the horizontal axis and vertical axis is 90 degree or perfectly they are at 90 degree, then the beta will be 0. It will go down as it is, it will go down like a perpendicular. But as it is not 90 degree, as the vertical axis is not 90 degree with the horizontal axis, so it will follow this kind of path. So obviously there will be some kind of error which is known as beta, as you can see the beta. So if this beta error is there, then we can calculate the P1, P2 from here. How we will calculate P1, P2? Simple. From this triangle, you
স্যার
see,
বিটা এরারটা একবার বলবেন?
হ্যাঁ বলো বলো।
বলছি বিটা এরারটা একবার বলবেন?
Yes. Suppose this is your theodolite, your lens. This is the line of collimation. This is the horizontal axis and this is the vertical axis. So if this is 90 degree, then after bisecting P, if you are going down in the horizontal trace, it will make an angle of 90 degree. But if this angle is not 90 degree, if this angle is say 89 degree, 59 minute, say 48 second, then obviously this will not make 90 degree. After bisecting P, if you are going down, it will not be perfectly 90 degree. It will follow like this curved path. Like even this is very small triangle, but I am drawing in an exaggerated version so that you can see it properly. So if it is perfectly going down, there is no triangle will form, right? Or simply the error is not there, so beta will be 0. But if it is not 90 degree, it will follow this sort of curved path. This is this sort of inclined straight line path. So there will be some kind of error here. So beta error will be here. You remember this angle, ideally it should be 90 degree, but it is not 90 degree, it is making say 89 degree, 59 minutes, 48 seconds. So this is 90 degree, that means this error will be how much? 12 seconds, right? The error will be how much? 12 seconds. That means if horizontal axis or the Trunian axis and the vertical axis are not perpendicular or are not 90 degree, suppose they are at 89 degree, 59 minute, 48 second, then the error between the horizontal axis or Trunian axis and vertical axis is 12 second, and hence this beta error also will be 12 second. Is it clear?
Yes, sir.
Okay. Now from this triangle P1, P2, so ideally it should go to P1, but it is not going to P1, it is going to P2, as there is some sort of error. So now this is one triangle, then there is another triangle. You can see there is another triangle like this one. In the horizontal trace, you can see this is P1, P2 and this is A, and the ultimate error which is E, right? This is the ultimate error due to this P1, P2. If P1 and P2 will coincide, this E error will not be there. These two lines are same. Our measurements will respect to AP1 line. But as our measurements is not happening with respect to AP1, rather it is happening with respect to AP2. So there is some sort of error E associated with that. So we will try to calculate E. Now from this triangle, as this is 90 degree, from this triangle, if you want to calculate tan E, then what it will be? It will be simple perpendicular bar base. So it will be simple P1, P2 by AP1, right? AP1. Now P1, P2 from this triangle again, as you know the beta, from this triangle you can calculate tan beta, and tan beta will be how much? Tan beta will be P1, P2 by PP1. Perpendicular is this one, base is this one, as this angle is 90 degree. So P1, P2 by PP1. That means P1, P2 from this we can write as PP1 tan beta. So this P1, P2 value will replace in this equation. So ultimately tan E will become PP1 tan beta. So tan E will be P1, P2. Instead of P1, P2 we'll write PP1 tan beta by AP1 is there. Now PP1 by AP1, that will again we can write from this triangle. As you can see, this bigger triangle, this one and this one. This is forming alpha 1 angle, this is A, this is P, and this is P1. So from this triangle we can write tan alpha 1 is equals to perpendicular PP1 by base AP1. So this PP1 by AP1, that is tan alpha 1. So tan alpha 1, tan beta. So you can see tan E will become tan alpha 1, tan B. Tan alpha 1, tan B, like this one. Tan E will become tan alpha 1, tan beta. Now, E and beta is very less. As in the example also I have given, beta is only 12 seconds. Similarly, E, the total error also will be very less, also in the dimension of few seconds, 1 or 2 or 3 or 4 seconds. Now, when your angle is very less, nearly equals to 0, at that time, we know that tan theta is nearly equals to theta, right? And due to that reason, as E and beta both are very less, we can write E instead of tan E and beta instead of tan beta. So in this way, we have calculated and we have approximated this equation tan E equals to tan alpha 1 tan beta to E equals to beta into tan alpha 1. But we can't write tan alpha 1 as alpha 1 because alpha 1 is a considerable angle, like 20 degree something minutes, 15 degree something minutes. So that is a considerable angle. So we can't write tan alpha 1 as alpha 1, but we can write tan E as only E, as the angle is very less, near to 0. So your error will be this one. Is it clear to everyone? If it is not clear, you can ask for. Is it clear to everyone? সবার কাছে কি এটা ক্লিয়ার হলো না কি আরেকবার বলবো?
স্যার আরেকবার বলুন।
আচ্ছা, কোনো পার্ট কি বুঝতে পারলি নাকি একদম ডেরিভেশনের ফার্স্ট থেকে বলবো?
একটু ডেরিভেশনের ফার্স্ট থেকে বলবো।
আচ্ছা, ওকে। See, while you are measuring, you should measure with respect to AP1. But instead of AP1, you are measuring with respect to AP2. Why you are measuring AP2? I am saying because when you will bisect P and going down, your path it will follow as this one instead of this one. So obviously there will be some kind of error beta. That beta is also the error between the this is a line of collimation, this is the horizontal axis and this is the vertical axis. That error is also the error between the horizontal axis and vertical axis. Ideally it should be 90 degree, but say if it is not 90 degree, if it is not 90 degree, if it is 90 degree, then it is okay, it will follow this path, no error will be there. Our measurements will be with respect to AP1. If it is 90 degree, measurements will be with respect to AP1. But if it is not 90 degree, not equals to 90 degree, then measurements will respect to say with respect to AP2. So then there will be some kind of error, right? So there will be, the error will be that much. The error we have to calculate, that means which is due to this P1 P2. Now before calculating that error, we have to know that if this angle is not 90 degree, say the angle is 89 degree, 59 minute and 55 second. So the error will be how much? The error will be simple 5 second. As what is the difference of the actual angle and the 90 degree angle? So that will be the error. That means whenever you after bisecting P, if you are going down, it will not follow PP1, rather it will follow PP2. So ideally, if it is 90 degree, this angle is 90 degree, your this angle will be actually 90 degree, or P2 actually will coincide with the P1. But as it is not 90 degree, it is 89 degree, 59 minute, 55 second. So obviously there will be some kind of error. That error is 5 second. Okay, this error ultimately is represented here. The error between the horizontal axis and vertical axis will form a triangle here, where it will form the beta angle here. So this is 5 seconds. So remember, this is one triangle, P1, P2. Now in the horizontal plane, when you are looking through this telescope, it is also forming another triangle like this one, P1, P2 and A. You do not have the problem between the line of collimation and horizontal axis here. This angle is 90 degree, and that's why our this angle will be 90 degree. Here we are only discussing the problem related to the non-perpendicularity between the horizontal axis and the vertical axis. But here the line of collimation is perfectly at 90 degree with the horizontal axis. There is no problem. So obviously this angle is 90 degree. So if this angle is 90 degree, what will happen? This will also form a triangle. Now if you look at this one, P1A, that means this one, whenever you are looking through your telescope, P1A, this is also forms a triangle where this is 90 degree. So these three are the triangle. Now what will be the actual error? Your actual error is this angle, E. Because your ideal measurements should be with respect to AP1, but you are measuring with respect to AP2. So this is the error in the angle measurements. So obviously E is the error. Now in this triangle, if you apply tan E, that will be how much? Tan E is perpendicular by base. So what is the perpendicular here? Perpendicular is P1, P2 and base is AP1, right? যে বুঝতে পারছিল না, বুঝতে পারছো? This is the perpendicular and this is the base. This is the perpendicular and this is the base. So perpendicular is P1, P2 and base is AP1. So this is tan E. So this we have to calculate. Now from this triangle, again you can write, as this is beta, you know. So from this triangle, again you can write, from this triangle you are writing tan beta is equals to perpendicular by base. So tan beta will be P1 P2 by PP1, right? So from here we can write P1 P2 is equals to PP1 tan beta. So P1 P2 is equals to PP1 tan beta. So instead of P1, P2, we can write whatever we have got from this triangle, this triangle. So this is one, and this bigger one is another. So from this triangle, we have got P1, P2 as PP1 into tan beta, just cross multiplication korche, PP1 into tan beta. So that we are writing PP1 into tan beta by AP1. Now from this triangle, as this is alpha 1 angle, if you calculate tan alpha 1, this will be perpendicular PP1 by base AP1. So you can see the PP1 by AP1 is here. So instead of this PP1 by AP1, you can write tan alpha 1 and into tan beta is there. So ultimately you are getting tan E is equals to tan alpha 1 into tan beta. বুঝতে পারলে? যে বুঝতে পারছিলে না বললে বা একবার এক্সপ্লেইন করতে বললে বুঝতে পেরেছো?
Yes, sir.
Okay. Now remember, whenever your angle will be very near to 0 degree, okay, say 1 second, say 2 second, or say 5 second, all these angles are very near to 0 degree. At that time, obviously, tan theta is nearly equals to theta. And due to that reason, as we know that beta is also very less, few seconds will be there in the error. The error will not be very much. So obviously we can write beta instead of tan beta as we are seeing here. Similarly, we can write E instead of tan E. But tan alpha 1 we have to write as tan alpha 1. So the ultimate error will be E equals to beta into tan alpha 1. Is that clear?
Yes, sir.
Now, actually you want to measure this angle. This is P, this is P1, this is Q, and this is Q1. And suppose this is your telescope. So you want to actually measure this A, P1, Q1. But you are measuring with respect to P2. Similarly, you are measuring with respect to you are measuring to Q2 instead of Q1. So if Q will form an angle of alpha 2, here also some error will be there, and that will be beta tan alpha 2. So ultimately the measurement error in the angle will be beta into tan alpha 1 minus tan alpha 2. And in this case also, if P and Q are at the same level, then the error will be nearly 0. That means when alpha 1 is equals to alpha 2, the error will be nearly 0, like the previous case also. Here also the similar case. The measurements in the angle will be beta into tan alpha 1 minus tan alpha 2. That means the measurements error in this one into the measurements error in this one. And it will be nearly 0 when both are at the same level, because at that time alpha 1 will be nearly equals to alpha 2. So the error will be nearly 0. But obviously if the level difference is there, the error will be there. And for that reason, what we will do here also similar thing, we have to take both face measurement. That means face left measurement first and then face right measurement second, and then we will take the average of these two. Because if you are getting this path by face left measurement, then you will get this path by face right measurement. At P1, P3 will be similar amount of error, but on the other side. So if you take both the side average, then obviously you'll get the measurement with respect to AP1. So the error can be eliminated by taking both face observation. Is that clear? Like the previous case. Is that clear? এটা কি ক্লিয়ার হলো?
Yes, sir.
জাস্ট যে এররটা এই সাইডে হচ্ছে, আমি যদি অন্য ফেসে নিই তখন এররটা উল্টো সাইডে হবে, তখন P1 P3 রেসপেক্টে হবে। তাহলে এই দুটোর অ্যাভারেজ নিলেই আমি P1 পজিশনের রেসপেক্টে পেয়ে যাব। ওই জন্য আমরা বারবার বোথ ফেস মেজারমেন্টস নিই। যাতে এই যে বি আর সি এই এররগুলোকে রিমুভ করা যায়। Now we'll discuss the another kind of error, that is non-parallelism of the axis of the telescope level and the line of collision. So if this kind of error is there, that is line of sight is not parallel to the telescope level. Telescope level means this one, you see, telescope level is there and this should be parallel to this one. So obviously if that is not parallel, then also some kind of error will be there, and this kind of error also you can omit by both phase measurements. Okay, now there could be error due to imperfect adjustment of the vertical scale vernier. That means the vernier which is in the vertical scale, if that is imperfectly adjusted, then also there will be some kind of error, and that kind of error you can get while measuring the horizontal angle as well as the vertical angle, as due to the imperfect adjustment of the vertical error, it will not be perfectly zero. When your telescope is zero, a telescope is horizontal, it will not be a perfect zero. That means there is some kind of index error is present here. So how to remove that? Either you have to do index error calculation and you have to apply that, or simple, you can take both phase measurement, like phase left swing right and phase right swing left. So both the phase measurements you will get and you will take the average of these two. So ultimately by this you can minimize that error, or you can uh, avoid that error. So these are the errors which we can move with the help of the both the phase measurements. Now there could be problem due to the eccentricity. Say your vernier is here. Say your vernier is say A is the position of the vernier. Suppose your theodolite is like this. We know vernier is at the 90 degree. When we have shown from the top level, we have seen that if this is the telescope, the vernier will be in this side and in this side, vernier A and B, right? So similarly, if in this case, say this is the telescope, and with the help of the telescope you want to measure one angle, say PAQ. So what you will do, you will first bisect this P, and then you will open the upper main screw and you will move your instrument, or specifically your telescope, so that the vernier scale will move, and ultimately you will bisect Q and this angle will be measured. Now whenever you are moving this telescope, your verniers are also moving. Verniers are always at an angle 90 degree to the telescope. Now say this is your vernier A, the position of the vernier A, when you are taking the back side, or when you are basically bisecting the P. Now suppose your telescope, now you have moved to this position, so obviously to bisect Q, so obviously your vernier also will move to a new position A1. Now your vernier B ideally is at a position B, and which is moved to B1. So if you, what is the center of this your verniers? If you add these two verniers, this is A and B, and if you add the new position of the vernier A1 and B1, this will be another line. So where they will cross, that will be the vernier center, or simply vernier is moving with respect to this center. But say your actual center of the circle of the main scale is O, then there will be some kind of error as O is not coinciding with O1. So then what will be the error that we have to calculate? So in the main scale, the reading will show with respect to OA O1, or you are basically measuring OA O1, but your actual movement is O1 A1, O1 A1. But you are measuring which angle? O A1. You are measuring this angle. You are measuring actually in the main scale. You are measuring actually You are measuring actually this angle, but you should measure this angle. So then what we will do? From the triangle perspective, you can know that AO1 A1, or simple you can draw this one. This is A, this is say A1, this is O, and this is O1. This portion I have drawn here. See. Now from here we know that the exterior angle or AOA1 will be this one plus this one, that we know. So A1 O, or we can write A1 A1, this angle plus this angle, or O1A O1A. So from this we can write AOA1, or this one, as AOA1 minus O1AO. Is this clear? These two steps is those two steps clear to everyone? কেউ বুঝতে না পারলে এখনই বলো বলো, আবার পুরোটা রিভিশন করে সে তখন অসুবিধা হবে। এই দুটো কি কেউ বুঝতে পারলে? কোনো জায়গায় অসুবিধা থাকলে বলো। Is these two steps clear? You are measuring this angle in the main scale. However, you want to measure, you should measure this angle, because your vernier is moving with respect to this center, right? But you are measuring this angle, so we have to do certain kind of calculation, or we have to calculate the error. Now if you draw in a magnified version here, you will see this is A, this is O1, and this is O, and this is A1. So your AOA1, this angle, AOA1, this angle should be ideally this plus this. We know this is, we have learned in class 7 these properties. So AOA1 is equals to obviously O1AO plus AO1O, or we can write AO1A1. So this angle. So that we have written. Now we can write A01A1 is equals to this minus this. So AOA1 minus O1AO minus O1AO. So this one will be equals to this one minus this one. So that we can write now, instead of AOA1 we will write different thing. Sorry, this one is, we have written in the, here we have written C, not O1. Sorry, this is written C. This is written as C. C, yes. So AOA1 sorry, write AO1 AO1A1. This one will be equals to ACA1 minus O1 AC, these two. But instead of C we can write O1AC, that means this angle. O1AC, we can write instead of that O1AO. So instead of O1C, we can write O1AO. Instead of O1AC, we can write O1AO. So that is okay, perfectly okay. A O1 A1, A O1 A1. That means this angle will be this minus this. Simple. This angle will be this minus this. So that what we are getting. Now instead of AC1, we will write something different. Let us calculate that. Instead of AC1, that means this part, A C A1. Instead of that one, we will write so this is again another triangle sort of things is forming. So obviously AC1 is the exterior angle. So that will be equals to this one plus that one. So AC1, ACA1, sorry, ACA1 will be equals to how much? Will be equals to this angle plus this angle. So this angle is AOA1, AOA1 plus OA1C. OA1C. But OA1C means this angle. Instead of OA1C, we can write OA1O1 because that is on the same line. So instead of C, we can write OA1O1. So that we can write instead of ACA1. So that too we have replaced. So instead of ACOA1, we have written AOA1 plus O1A1O. Where is O1? Instead of ACA1, it will be ACA1 is this one. Instead of that, it will be this plus this. So this will be AOA1. Okay, AOA1 plus OA1 O1. OA1 O1. ठीक है. So this is the equation you are getting. If you are not able to understand, just apply, just go through the steps. Only one step is there, that is the external angle will be the summation of the opposite to interior angle. This equals to this plus this. Only these things has been applied in these two triangles. Just go by this, you can easily see how this equation is coming. Now as we have got this angle or this equation, so if you write down freshly, so you can see whatever we have written, that is AO1 A1. That means this angle ideally should be AOA1 AOA1, that means this angle plus O1A1 O, that means this angle, and minus this angle. So this plus this minus this. Similarly, for the B also we can write BO1 B1, like BO1 B1, this angle is equals to this angle BO1 B1, this angle will be equals to BO B1, or simply this BO B1 this plus O1 BO. So O1 BO, this angle. This plus this O1 BO minus this angle O1 B1 O. O1 B1 O. This will be B1. So, oh, sorry. This is okay. This is the next equation. Next equation. O1 B O1. This line we are looking. O1 B1 O. So minus O1 B1 O. Or this angle we have to deduct. So to measure this angle, this will be this one plus this one minus this one. Now we want to measure this angle and this angle, but instead of that, we are measuring this angle and that angle. So what we will do, we will just add them up. So, and before adding them up, what we will write from this long triangle, as you can see, A, B, O. If you look at this long triangle, this angle will be equals to this angle because this is the diameter, this two is same, so obviously these two angle will be same. So obviously this suppose this is O1, so O1AO O1AO will be similar, O1AO will be similar, O1BO will be similar to O1AO. So O1BO will be same to O1BO is same to O1AO. So this two angle is similar. That's why we have written BO1 B1, which is equals to BO B1 plus O1 BO minus O1 B1 O will be replaced by the value of this one. As O1 BO we already know is O1 AO. So we have replaced this one O1 AO. And instead of O1 B1 O, similarly, if you look at this triangle, this bigger triangle, like this, where A1 and B1 is there, and here in between O1 is there, here O is there. So O1 B1O or this angle will be equals to this one O1 A1O. So that's why instead of O1 B1O we have written O1 A1O. Now we have got equation 1 and 2, so we'll add them up. So when we are adding the left hand side, it will be A O1 A1 plus B O1 B1, which will be equals to this part minus this one plus this part minus this one. Now you can see O1 AO will cancel out and O1 A1O also will cancel out. So ultimately it will be AO A1 plus BO B1. And you know these two angle is same. These two angle will be same, equal and opposite angle, right? So AO A01 A1 will be equals to B1 B1 O1 B. So ultimately these two angle is similar, and that's why we have written 2A O1 A1, and that will be here we are getting AO A1 plus BO B1. So ultimately A1 A1 will be the average of these two, and that's why we always take both the verniers reading. Here it will give B1 O B1 is basically the vernier B's reading, and A1 is basically vernier A's reading. So ultimately we take the average of both the verniers and we tell that this is our data. So ultimately error of the eccentricity of these two axes can be removed by these two verniers. About the derivation, it may be hard to follow the lines when I am telling you BO B1 like this, because there is so much suffix and all these things are there. But once you will go through this and you will practice once, even by seeing the PPT slide, if you at least practice once this whole part in your exercise book, you will see this is very easy. Only one thing is used here, that is the external angle is summation of the internal two angles of a triangle, and also equal and opposite angles are same. Only these two things are used. So obviously this is very easy derivation. You can go through this. It will be very easier one. Ultimately, as you are measuring only these two angles, so to get the actual data, you have to take the average of these two. So that's how we will get the actual reading. You have to take the both the verniers reading, and that is the reason why instead of in the horizontal plate also you are having you are having vernier A and vernier B, so that you can take the average of vernier A and B, and also in the vertical circle also you are having vernier C and vernier D, so that you can take the average of both the two, because so that you can error this eccentricity error. Okay. Now there could be imperfect graduation, as we have told you in the beginning of the class, that suppose in this one quarter 0 to 90 degree graduation should be there, but instead of that here suppose 89 degree up to graduation is there. That means in quarter here you should see 90 degree, but you are seeing 89 degree. That means all this graduation are little bit spaced in with a little bit more gappings, right? And suppose here you should see 180 degree, here you are able to see 180 degree, so here 89 degree, here 180 degree. That means the rest 91 degree is accommodated here in place of 90 degree. So obviously here gappings between all the divisions will be less compared to the actual division. So obviously when you will take the measurement in this segment and you are suppose getting the 20 degree, maybe it is not the actually 20 degree, maybe it is actually more than the 20 degree. Suppose 20 degree some minutes, but you are actually getting 20 degree. Similarly, if you measure here 20 degree, it may be actually not 20 degree, it may be actually 19.88 degree, which is shown here as 90 degree, right? So similar sort of problem will be there. Here the long actual larger measurements will be shown as a shorter dimension. So like 20 degree 20 minutes can be shown as a 20 degree, and here lesser angle actual angle can be shown as a larger angle if the graduation is not perfect. And to avoid this problem, what we do, we don't measure the angle like only we are making the vernier A as 0 while bisecting P or taking the backside, and then we are bisecting Q. No, we don't do that. At the time of measurements also I have said make 0 as the make vernier A 0 when you are bisecting OP. But actually you will start with 0, then with the 0 you will do the measurements, then with the help of the 90 you will do the measurements, then we will do the measurements making OP line as 180 degree, then you will measure the OP angle with making OP angle as 270 degree, so that in every quarter you are having the measurements. So then only you are having this sort of several measurements, and you can take the average of this sort of measurements, then only you will get the actual degree. Is that clear? Is it clear to everyone, or I will explain again?
Yes, sir.
So in different quarters you have to take the measurements, otherwise this sort of error you can't remove. Then there will be error due to eccentricity of the verniers. That means the vernier A and B ideally, obviously, should have been at 180 degree difference. But when you are seeing the vernier 0 in the main scale, you are taking the reading. The vernier B, when you are seeing the 0 and you are taking the reading, and that is not showing 180 degree difference, but rather if it is showing say 180 degree 20-second difference, but or 179 degree 20-second difference, then what you will do? 170 degree 00 minute 20 second and 179 degree 59 minute 20 second. So this kind of say 20 seconds error or some error is there, then what will do? How to remove the error? Then also your measurements will be erroneous. So how to remove this sort of error? You have to take the mean of the both the verniers reading, right? Then only you can remove the this sort of error. So obviously this sort of error you can see, you can just remove by taking both uh, both the verniers measurements. Okay, so here both vernier measurements, these also both verniers measurements. Previously all are basically doing the both face measurement, and this one by taking at different starting point. That means 0 degree starting line, 90-degree starting line, like this. Now all these errors, you know, already we have discussed. Now there could be some other sort of error also, like partial error and error in citing and reading. Personal error. Personal error can be of two types, like error in manipulation and inaccurate. Sorry, errors in citing and reading. So error in manipulation means at the time of centering, some sort of error is there. So if you are doing inaccurate centering, so you should look at the plan view. Say you are at a point C and you want to measure this ACB angle. Then what you will do at the C, you will center your instrument. You will take the back side, or you will just bisect the A and you will make your vernier 0, 0, and then you will open your main upper main screw and you will remove your, you will rotate your telescope, you will bisect B, you will tighten your bisect and you will measure the angle. But suppose this centering is wrong. Suppose the point is where you have centered is basically at this point, at C1, like this one, at this point. Your ground point is relatively at a different point than C. Then instead of this, you are actually measuring this angle. Instead of this angle, you are actually measuring this angle. So instead of ACB, you are actually measuring AC1B, right? So you are doing some sort of measurmental error. So obviously ACB measurements which you should do, but you are actually measuring AC1B. So you are doing some sort of error in the measurements, and your error will be alpha plus beta, if this is alpha and this is beta. Now this error could be plus minus alpha plus beta, depending on the position on which side you have centered, in this side or in this side. So depending on that, it will be plus minus alpha plus beta. That means alpha plus beta, either it should be plus or either it should be minus. Now this sort of error will be very problematic when you are doing the survey for a very little part. Okay, because for doing a very little part survey, if you are erroring, if you are doing an error in the centering of 1 centimeter, suppose you are making an error of 1 centimeter, even that will cause also some error. Okay, so suppose if you are doing a centering error of 1 centimeter, say this is 1 centimeter, and the site is suppose your 32-meter long, then your error will be 1 second in this dimension. Error in the angle. So this error will be around 1 second in that case. But if your side distance is very less, if for a very lesser side or very smaller part, your centering error is considerable, then your error also will be considerable. But for a very larger part of survey, this error will not be that much. Okay. So for that reason, what you have to do? You have to do the temporary adjustment properly, or you have to do the centering properly. Similarly, leveling, if the level is not adjusted properly, some kind of error will be there, as we have spoken in 1.a, that kind of error will be there. So you have to do proper leveling. So this is also comes under the inaccurate leveling error, which is also partial error. Then there is slip kind of error. Slip is when basically your clamp is not tightened properly. When your clamp is not tightened properly, there will be some movement, and that movement will not be the movement when it is properly free. That sort of movement also will not be there. So some sort of slip will be there, and due to that slip between two plates or between the any part of the machine, some sort of loose portion, if it is some loose connection is there, if it is not properly tightened, the screws are not properly tightened, then some sort of error will be there, and that is slip. Now this sort of error very hard to remove, so obviously you have to be very serious while taking the measurements. You have to be very cautious in taking the measurements. Okay, because suppose if you are bisecting, suppose you are taking the measurements at p o q and you have bisected p, and suppose your lower main screw is not properly tightened, so now if there is any slip, p will change to p dashed, right? So this sort of error will be there, so that's why slip should be avoided. Okay, so you have to work properly. Then also the manipulation of wrong tangent screw. Suppose you have bisected P and you have made this line as 0 0. Now you have opened your upper main screw, you have opened your telescope, and you have bisected Q approximately. But true bisection you have to do with the help of the upper tangent screw. But instead of upper tangent screw, suppose you have moved lower tangent screw, then what will happen? Lower tangent screw, if you will move, then there will be some error, because lower tangent screw means the movement of the instrument will be there, but the measurements will not be there. So what will happen? That you can see that your object is properly bisected, but that small amount of measurements will not be there in the scale, because that you have done with the help of lower tangent screw, or I should say bottom tangent screw. So no measurements will be there. So that's why you have to be very cautious while rotating the tangent screw also, because if you manipulate the wrong tangent screw, obviously there will be some sort of error. So this sort of error you can't minimize by taking multiple observation, rather you you have to be very cautious in taking the measurements. Now then there is inaccurate bisection. If the object is not bisected properly, then also some error will be there. Okay, so you have to bisect the object properly. You have to keep the ranging rod at the station at first. Suppose at a ground station the station is there, near here one ranging rod should be there, so that ranging rod you can bisect easily, then you can come down and you can bisect the object properly. Okay, so in this way you have to bisect. Then you have to move the parallax error, because the objective and eyepiece should be properly focused. If it is not properly focused, then parallax error can be there, and this is also coming in the temporary adjustment, and you have to do properly temporary adjustment. Then also mistake, this is the part, if you are doing some kind of mistake in taking the measurements or writing the readings, this kind of errors can be there. Then there is, sorry, this is not the personal error, natural error. So then there is natural error can be there due to the inaccurate atmospheric refraction due to high temperature. So whenever there will be high temperature, all the layers will have different kind of density. So obviously the object will come from a long way, so ultimately it will pass through the reflection different refracting medium. So due to that some error will be there, but this sort of error will not be very much when you are dealing with a very smaller part of your area. But suppose you are bisecting, or if you are taking the measurements of sun, like we do in the case of azimuth determination, in that case we point our telescope towards sun, right? And we keep the sun like in our telescope crosshair like this. So at the time of azimuth determination, we done that this will be problematic if there is high temperature, because then it will be very problematic, because it is the sun rays is coming from a long way and it is passing through different kinds of layer which is having different refracting index. So obviously that will also be problematic. Then unequal expansion of the part of the telescope. So some part is made up of metal, some part of is made up of glass. So due to that, some unequal expansion will be there. Then unequal settlement of the tripod. While taking the measurements, if these three legs, one leg is settled, if this all three are settled equally, then there is no problem. But if one leg is settled, others are as it is, then obviously there will be problem in the taking reading. Then wind producing vibration, that will also create some problem. So these are the types of the errors. Most of the errors, as you have seen, instrumental errors, which we can remove by some both phase measurements and taking the average of the vernier A and vernier B. We can avoid those errors. And the personal errors, you have to be very cautious in dealing with the personal errors. So your home task will be to study this theodolite survey properly. If you are having any confusion, on the next day will tell me, because on the next day we'll do the numericals depending on the traverse survey, and this part should be clear, otherwise you are not able to do any kind of numericals. So please go through these slides enough. uh, Written material is there already in our slides, so if you go through the slides you can understand properly. Also, what is your home task? That will be, you will note down all the errors in a table, and how to remove the errors, that you will note down like on a tabular form. Please make a table like the personal the instrumental error. The error name is, say, error due to horizontal axis not being perpendicular to the vertical axis. And how to remove that? By taking both face measurement like this. Make a table, what are the types of errors and how to remove them. Just this is your home task. uh, Please do these things before coming in the next class. Please do this part, okay? And also study this traversing part, this theodolite part very carefully. Today I will upload this PPT, means the rest of the part of the PPT in your classroom. Please go through this. If you are facing any problem, you can ask me in the next class, because in the next class we'll go for the measurements. And if it is not clear, obviously in case of the measurements it will be problematic. So that's all for today. If you are having any question, you can ask. Otherwise, we have discussed, or we have completed the module 2. The module 3, where we will basically discuss the numerical parts of your theodolite survey, as well as some error, uh, how to avoid the errors and all these things, that we will discuss in the module 3 or the traverse survey. So তোমাদের কারো কোনো কোশ্চেন থাকলে জিজ্ঞাসা করতে পারো, এলস আজকের জন্য ক্লাস এখানেই শেষ। মডিউল 2টাও আমাদের শেষ হয়ে গেছে। মডিউল 3 আমরা নেক্সট দিন করব। এখানে আমরা নিউমেরিক্যালস গুলো ডিসকাস করব। অতএব এই পার্টগুলো যেন ক্লিয়ার থাকে যে কোনটা দিয়ে কি রিমুভ হচ্ছে। এন্ড একটা টেবিল তৈরি করো যেখানে এরর গুলো লিখে কোন এরর গুলো কিভাবে মিনিমাইজ করা যাবে। এই টেবিলটা কিন্তু আমি নেক্সট দিন দেখতে চাইবো। টেবিলটা করে সেটা একটা পিডিএফ স্ক্যান করে রাখবে, মানে এক পেজে করবে, জাস্ট শুধু এররটা এবং তার সেটাকে কিভাবে মিনিমাইজ করব, নট দা মেজারমেন্টস কি হবে সেই জিনিসগুলো লেখার দরকার নেই। মানে ওই যে বিটা সেক আলফা, বিটা ট্যান আলফা, বিকজ আলটিমেটলি ওই জিনিসগুলো লাগবে না, ওগুলো তোমাদেরকে বোঝানোর জন্য। হাউ টু মিনিমাইজ দোজ এরর্স, প্লিজ মেক এ টেবিল। ওকে, বোঝা গেছে কি বলতে চাইছি?
স্যার আরেকবার বলবেন, একটু কনফিউজ হয়ে গেলাম।
কোন পার্টটা কি করতে হবে সেটা?
ইয়েস, টেবিলটা।
টেবিলটাতে এরর গুলোকে একটা কলামে রাখবে, আর তার পাশের কলামে রাখবে ওই এরর গুলোকে কিভাবে রিমুভ করবে। ঠিক আছে? মানে ধরো এই অ্যাক্সিসটা এটার সাথে পারপেন্ডিকুলার নয়, সেটাকে কিভাবে রিমুভ করছি, বোথ ফেস মেজারমেন্টস বা ফেস লেফট এন্ড ফেস রাইট মেজারমেন্টস। এইভাবে রিমুভ করব। এই দুটো শুধু পয়েন্ট থাকবে, এইভাবে প্রত্যেকটা এরর এবং সেগুলোকে কিভাবে মিনিমাইজ করব এইটা একটা টেবিলে করে ফেলবে। তার
ওকে স্যার।
মেজারমেন্টগুলো লেখার দরকার নেই যে বিটা সেক আলফা বিটা ট্যান আলফা, ওগুলো লেখার তো দরকার নেই, কারণ আলটিমেটলি ওগুলো তোমাদের কোনো কাজে লাগবে না, তোমাকে জাস্ট এই মেজারমেন্টস গুলোকে কিভাবে রিমুভ করতে হবে সেটাই জানতে হবে। ঠিক আছে?
ইয়েস স্যার, আন্ডারস্টুড। স্যার এই মডিউল 2টা আপনার ক্লাসরুমে পেয়ে যাবো, গুগল ক্লাসরুমে?
মডিউল 2 এর হ্যাঁ অনেকগুলো পার্ট অলরেডি আপলোড করা আছে, লাস্ট পার্টটা আপলোড করে নেই, ওটা আপলোড করে
ওকে,
দেবো আজকে।
ঠিক আছে, থ্যাংক ইউ।
এই পুরো পার্টটা মডিউল 2টা করে রাখবে, তার না হলে কিন্তু মডিউল 3টা বেসিক্যালি আসলে মডিউল 2 আর মডিউল 3 হচ্ছে একটাই মডিউল, বেসিক্যালি এই দুটো কন্টিনিউয়েশন মডিউল। মডিউল 3টা ট্র্যাভার্স সার্ভে, ট্র্যাভার্স মানে একটা এরিয়াকে তুমি সার্ভে করছো, তার বিটুইন অ্যাঙ্গেল অবশ্যই থাকবে এবং তাতে কিছু এরর থাকবে, সেই এররগুলোকে কিভাবে মেজার করবে এবং কোনটা এক্সাক্ট অ্যাঙ্গেল হবে, এই জিনিসগুলোই আমরা পরের মডিউলে ডিসকাস করব। সেখানে মেথড অফ রিপিটেশন, মেথড অফ রিইটারেশন সব কিছু থাকবে। ফলে আলটিমেটলি এই পুরো মডিউল 2টাকে কিন্তু করে ফেলবে, না হলে মডিউল 3তে কিছুই বুঝতে পারবে না। ঠিক আছে?
ইয়েস স্যার। স্যার নেক্সট ক্লাস আপনি নিউমেরিক্যালস করাবেন কি?
হ্যাঁ, ট্রাভার্স সার্ভে
ওকে
তাতে
স্যার,
স্মল কিছু একটা পার্ট বলে তারপরে নিউমেরিক্যালস করাতে হবে।
ঠিক আছে স্যার, থ্যাংক ইউ।
মেইনলি নেক্সট মডিউলটাই হচ্ছে মেইনলি নিউমেরিক্যালস এর মডিউল, মানে খুব কম থিওরি আছে। বেসিক্যালি যেহেতু বললাম দুটো পার্ট অ্যাকচুয়ালি ইন কম্বিনেশন, তো এটাতে মেইন পার্ট হচ্ছে থিওরিটা, ওটাতে হচ্ছে মেইন নিউমেরিক্যালস।
অ্যাটেন্ডেন্সের লিংকটাকে দিয়েছেন স্যার?
লিংকটা অ্যাটেন্ডেন্সে দিয়ে দিয়েছি তো চ্যাট বক্সে। রমেশ আহমেদ কি বলছো?
স্যার
Yes,
অ্যাটেন্ডেন্সটা আরেকবার দিন তো।
দিলাম তো, আরেকবার দিলাম,
স্যার আমি বেরিয়ে গেছিলাম স্যার।
এক্ষুনি দিলাম, দেখো এলে সুইচ অ্যাকাউন্ট
না স্যার পাইনি।
এই তো এক্ষুনি দিলাম তো, 11:43 এক্ষুনি দিলাম।
ওকে স্যার, পেয়েছি।
এররের পার্টগুলো কিন্তু এতটা ডিসকাশন করতে হতো জাস্ট এররগুলোকে বোঝানোর জন্য, কিন্তু আসলে এররগুলোকে আমরা কিভাবে রিমুভ করব সেই পার্টটাকে তোমাদেরকে জেনে রাখতে হবে। এটা কিন্তু একটা টেবিলটা সবাই ইন্ডিভিজুয়ালি বানাবে, ইন্ডিভিজুয়ালি নিজেদের খাতায় বানাবে, কারো থেকে কপি করবে না, স্ক্যান করে রাখবে এটাকে। ঠিক আছে? ইন্ডিভিজুয়ালি বানালে পড়ে পড়ে বানাবে, পুরোটা পড়বে যে কিভাবে কি এরর হচ্ছে এবং তার এররটাকে কিভাবে রিমুভ করব। জাস্ট টেবিলটা বানিয়ে রাখবে যে কোন এররকে কিভাবে রিমুভ করব, কারণ এই এররটা তাহলে কি হবে তোমাদের জন্য যে কোনো টাইমে একবার দেখে নিলেই যে এই প্রসেসটা করলেই এতগুলো এরর রিমুভ হচ্ছে। বুঝতে পেরেছো? তাহলে এই জিনিসটাকে করে রাখতে হবে।
স্যার
বলো
স্যার
বলো।
বলছিলাম হলো আমরা ল্যাটারাল এখনো গুগল ক্লাসরুমে জয়েন হতে পারিনি, ওটা কিভাবে হবো?
আচ্ছা, তোমাদের সবার মেল আইডি কি আমি পেয়েছি, আমার কাছে এসেছে?
স্যার আপনার কাছে আসেনি, আমি পাঠিয়ে দিচ্ছি আপনাকে। সবার
প্রথমে এক কাজ করো, আমি দুই সেকশনের শেয়ার মানে এ আর বি, তোমরা আমাকে একটা পিন করো, আমি ওই গুগল ক্লাসরুমের লিংকটা পাঠিয়ে দেবো, ওই লিংকটা ওদেরকে পাঠিয়ে দিলে ওরা ওই লিংক দিয়ে জয়েন করে যেতে পারবে।
আচ্ছা ঠিক আছে।
প্রসূন তো আমি প্রসূনের তো নাম্বার রয়েছে, আমি প্রসূনকে একটা লিংক পাঠিয়ে দিচ্ছি। আর এই
হ্যাঁ, স্যার।
সেকশনে কে রয়েছে শেয়ার?
এই সেকশনে দেখছি, দাঁড়ান স্যার, এখানে অ্যাট প্রেজেন্ট কি আছে দেখতে হবে।
আচ্ছা পবিত্র, তাহলে তুমি পাঠিয়ে দিও, আমাকে একটা পিন করে দিও, আমি তোমাকে লিংকটা পাঠিয়ে দেবো।
ওকে স্যার, ওকে স্যার।
ঠিক আছে?
হ্যাঁ স্যার।
আবারও বলছি থিওরিলাইট পার্টটা কিন্তু ভালো করে পড়বে। এটা আমাদের সময় সেকেন্ড সেমিস্টারে থাকতো, আমরা যখন স্টুডেন্ট ছিলাম, মানে সেকেন্ড সার্ভেতে থাকতো, অলরেডি একটা আইডিয়া থাকতো। তোমাদের যেহেতু সার্ভে সিলেবাস মডিফাইড, অনেক নতুন কিছু এসছে, সেই কারণে এই পার্টগুলো পার্ট ওয়ানে এসছে। বাট পার্ট ওয়ানের সার্ভে বোঝার জন্য থিওরিলাইট অতটা ইজি জিনিস নয়, প্লাস তোমরা চোখের সামনে দেখতে পাচ্ছ না, তাই আরেকবার ভালো করে পুরো জিনিসটা পড়ো, না পড়লে নেক্সট দিন যখন নিউমেরিক্যালস করবো কিছু বুঝতে পারবে না। তাই ভালো করে আরেকবার করে পড়ে নাও কিভাবে এররগুলো মিনিমাইজ হচ্ছে, কিভাবে মেজারমেন্টস নিচ্ছে, যা যা ডিসকাশন এতদিন করা হয়েছে সেই পার্টসগুলোকে খুব ভালো করে পড়ো নেক্সট দিন মানে ক্লাসে আসার আগে। জানি না বলার পরে কজন পড়বে, কিন্তু আমার বলার কাজ বললাম, না হলে বুঝতে পারবে না।
আর স্যার আপনাকে পিং করে দিয়েছি স্যার।
ঠিক আছে।
স্যার সামনের সোমবার ক্লাস হবে তো?
হ্যাঁ, সামনের সোমবার কি কত তারিখ পড়েছে?
আমাদের 2 তারিখ পড়ছে বোধহয়।
না 1 তারিখ পড়েছে মনে হয়। তোমাদের কালী পুজো কত তারিখে ছুটিতে পড়বে মনে হয়? 2 তারিখ না?
আর কালী পুজোর ছুটি তো স্যার কিছু নোটিশ
দেবে দেবে তো অবশ্যই। 3/4 মনে হয় পড়বে হয়তো, বা এরকম কিছু 4 থেকে।
স্যার কালী পুজোর কতদিন ছুটি আছে?
হ্যাঁ, কি কালী পুজোর
কতদিন ছুটি দেয়?
হ্যাঁ, কালী পুজোর ছুটি থাকে।
কতদিন? কালী পুজোর দিন না?
কালী পুজোর দিন থাকবে, তারপরের দিনটা এবং ভাতৃ দ্বিতীয়ার দিনটা 4, 5, 6 মনে হয় ছুটি থাকে। তো তাহলে পরের উইকে তো অবশ্যই হবে, কোনো মানে অসুবিধা নেই। আর মানে একই ক্লাস কম হয়েছে বলে আলটিমেটলি শেষ করতে হবে। খাবার সার্ভেটা করে তারপরে আমাদের লেভেলিং আর ট্র্যাকিওমেট্রি আছে, অনেকগুলো মানে মডিউল, কিভাবে কমপ্লিট হবে কে জানে। ঠিক আছে, অ্যাটেন্ডেন্স দেওয়া হলে বেরিয়ে যেতে পারো তোমরা।
স্যার বলছি সেমিস্টার কি ডিসেম্বরে না জানুয়ারি?
প্লেন
দেখো
টেবিল
বাকিদের
সার্ভে
সেমিস্টার তো
মানে
আলাদা, তোমাদের সেমিস্টারের টাইমিংটা আলাদা হবে। তোমাদের একবার আমাকে ওই ইয়েটা শিডিউলটা দেখে নিতে হবে, আমার ওটা এখন মনে নেই। একাডেমিক যে ক্যালেন্ডারটা ওটা দেখে তোমাদেরকে জানাবো।
ক্যালেন্ডারের হিসাবে তো স্যার লাস্ট উইক অফ ডিসেম্বর।
সেকেন্ড ইয়ারেরটা আলাদা রয়েছে দেখবে।
হ্যাঁ স্যার, থার্ড সেমিস্টার।
ঠিক আছে ঠিক আছে, তাহলে ওই ডিসেম্বরটাই হবে। আর যে জানুয়ারিতে যেতেও পারে, কারণ ক্লাস তো কম হয়েছে, জানি না কি হবে অ্যাকচুয়ালি।
থ্যাংক ইউ।
ঠিক আছে, এই সবার অ্যাটেন্ডেন্স দেওয়া হয়েছে, ইয়ে করবো স্টপ রেসপন্স হয়ে গেছে মনে হচ্ছে, ওনাকে দিয়ে দিয়েছি। এন্ড করছি কল, এ সেকশন অ্যান্ড বি সেকশন।